Lesson 21-3 is going to talk about exponential graphs and asymptotes. So we are going to be using the 21-3 note sheet to go along with today's lesson, something to write with, and you are going to probably want a calculator or Desmos for today's lesson. Okay. So we have 3 targets today that we're going to be talking about. The first one is to determine when an exponential function is increasing or decreasing. So let's talk about that. Here I have 4 graphs, increasing graphs and some decreasing graphs. So a function is said to be increasing if the y values increase as the x values increase. Okay, so what that means is we read a graph just like we would read a sentence. Okay, so as we move from left to right, what is the y value doing on those graphs? Okay, so for these increasing graphs, you can see as it starts low and as we move to the right, that function is going up. It's increasing. Same thing with the second graph here, even though it's kind of flipped around, same thing as our graph moves to the right, our function is going to be increasing by going up like this. Okay, that's an idea of an increasing function. This we would call our exponential growth. Okay. A function is said to decrease if the y values are decreasing as the x values increase. So as the graph goes from left to right, a function is decreasing or in decay if those y values are decreasing, okay, going down as we move through the function. Same thing here. We're starting high, but then it curves downwards. This would be an example of exponential decay. So that's what it means for a function to either be increasing or decreasing. We just look at how the function is moving as the x value is increasing. Is the graph going up from left to right, or is it moving downwards from left to right? Okay. So another thing we need to point out here is to notice how the graphs start to flatten out. So maybe I'm going to erase this here. But on each graph, whether it's on the bottom of the graph or the top of the graph, our graphs start to flatten out. Okay, and I'll show you kind of where that happens. I'll get a line here. So in this particular problem, you see how this kind of curves and it starts to kind of straighten out? It's happening about here. Okay. Same thing. Let's just duplicate this. Okay, same thing on this increasing graph over here, graph B. The graph increases until it kind of hits this x-axis and then it starts to flatten out. So the reason that graph starts to flatten out is because exponential graphs have what are called horizontal asymptotes. Okay, and they're always at y equals some number, so it just depends where the graph flattens out. So on both of these graphs here, it's flattening out at 0. That's the x-axis. So as you can see on these graphs here, the asymptotes are at the x-axis, so that would be at y equals 0. Okay. And an asymptote is a line that the function approaches but will never actually cross. Okay, we could expand this graph off as much as we want, but if the graph's going to continue to kind of get closer and closer and closer to this asymptote, but it will never actually touch it or cross it. That's the job of an asymptote. Kind of acts like an invisible fence for a function. Okay, again, you can get really close to that fence, but you can't actually cross it or touch it. That's what an asymptote is. Okay, and the asymptote is extremely important when we talk about end behavior. So remember, end behavior talks about what the graph is doing at the two far extreme ends. Okay, so we always did it. We never really used the infinities like this. We went left and right. Okay, and we said it's either going to infinity or some value, or we would say up or down. So in this time, we kind of can't just say up or down. We have to say what it's approaching. Is it approaching the asymptote, or is that graph approaching infinity? It's going up forever. Okay, so we'll talk about this notation here, but anytime it says as x approaches negative infinity, this is talking about what's the graph doing on the left side. Okay. Anytime it says as x approaches positive infinity, that's talking about what the graph is doing as it moves to the right. Okay, we just have to fill in what y is doing. Is it approaching our asymptote or is it going to infinity? So if we identify the end behaviors from the graphs above, let's look at graph A. Let me erase all of this extra stuff that we have. Okay, so if we talk about what's happening on the left side of the graph and the right side of the graph. So left side, right side. What is the y value doing? Well, on the left side, we could see it's approaching and starting to flatten out. That's what it means to be approaching our asymptote. So for our end behavior on this one, y is approaching the value 0, because that's where the asymptote is. That's where the graph starts to level out. As we look at the right side of the graph, well, what's our function doing as it moves towards the right? Well, it's increasing forever. So on the right, the y is approaching positive infinity. So that's what it means to talk about the end behavior. Now, the x value is never going to change. We just have to basically fill in every time what's the y doing. Okay, so not too bad. We just have to say either it's approaching the asymptote or it's approaching an infinity. So let's look at graph B. Okay, let's talk left side, right side. So as the graph moves towards the left, we can see that this graph is going down forever on the left. So if it's going down forever, where would y be approaching then if it's going down forever? Well, hopefully you said negative infinity. Okay, if it's going down forever, that's approaching negative infinity. As the graph moves to the right, okay, this graph is going to kind of curve and then start to level out because it's getting close to that asymptote. So in this particular problem, the asymptote is at 0. So y would be approaching 0. And then again, it's going to get really close to 0, but it's never actually going to be 0 or be anything higher than 0. Okay, so why don't you guys try C? So in graph C, I'm going to delete these lines now. We don't really need them anymore. So you can see the graph all the way. Okay, so in graph C, what is the graph doing as it moves to the left and as it moves to the right? So on the left, where is that graph going? And on the right, where is that graph going? So you're just going to fill in the parts here next to the y. Okay, so if we look at graph C, y on the left is going up forever. So that's headed towards positive infinity. While on the right side, the function kind of curves and then starts to flatten out. So it's approaching our asymptote at 0. Okay. One last one. Let's look at D. As this graph moves to the left, where is it headed towards? And as the graph moves to the right, where is it headed towards? Well, as it moves to the left, it's headed towards 0 because it's approaching that asymptote. And as it moves to the right, that graph is decreasing forever. So it's headed towards negative infinity. So again, for the x part, you never have to fill that in. You just have to fill in what the y is doing. Okay? Is it either approaching an infinity or is it approaching your asymptote? Now, the asymptote won't always be at 0. It just was for these examples. Okay, flip the graph on the next page, or on the back here, and let's talk about the y-intercept. So in previous video, we looked at this general form for a exponential function. So remember, if we have y is equal to a times b to the x. The b term we learned yesterday talks about our growth or decay factor. Okay, remember, if b was bigger than 1, it's growth. If it's less than 1, it's decay. So the thing we're going to learn today is where the y-intercept is. And the y-intercept is always going to be at that a value. So your coefficient will always tell you your y-intercept. So for example, if we have to identify the y-intercept for problem A, 3 times a half to the x power, well, this is a times b to the x. Your a term would be 3. So our y-intercept would be at 0, 3. Remember, a y-intercept's a point, and it's where it crosses the y-axis. So your number is always going to be in the y value spot. Okay. Similarly, with number b, if we have y equals negative 1/3 times 5 to the x power, the a value is your y-intercept. So our y-intercept is going to be at 0, negative 1/3. So what's our y-intercept at c? So in c, we have negative 2 times 4 to the x power. Where's the y-intercept going to be? Well, hopefully you said at 0, -2. -2 is the coefficient, so that is your y-intercept. Okay. All right, the last thing we're going to do is kind of put these key parts together a little bit. We're going to look at the graph of the function on Desmos and identify if the function's increasing or decreasing, talk about where the asymptote is, the y-intercept, and we'll do end behavior. Okay, so let's look at A. I'm going to go ahead and put these in Desmos. Now, I already have this set up for us, so we're just going to look at one graph at a time here. But if I look at the first graph, -3 times 2 to the x, would we say this graph is increasing or decreasing? And again, you can always zoom out if you need to or move the graph around. But this graph would definitely be decreasing. It's going down if I look at the graph from left to right. That is decreasing. Where is our asymptote? So looking back at the graph, where does it start to level off at? Which y value? Well, we can kind of see it's starting to level off. Not perfect, but about there. Now that's at the y value of 0. So that means our asymptote here would have to be at y equals 0. Okay, we don't really need the graph for it, but our y-intercept should be that number in front, so 0, -3. And again, you can check that on your graph. You just have to click where it crosses your y-axis. It'll tell it to you. Okay, and then the last thing we have to do is just talk about end behavior. Erase this. Okay, so remember, end behavior is talking about what's the graph doing as we go on the left, and what's the graph doing as it moves to the right. So on the left, what's this graph approaching? Well, it's approaching our asymptote. So that would be at 0. Remember, that is as x goes to the left and as x goes to the right. We just said as it goes to the left, the y is approaching the asymptote. If I look at the graph, what is it doing as we move to the right? Well, it's going down forever. So if it's going down forever, our right side is approaching -infinity. Okay. Let me go through one more with you guys. Let's look at B. Y equals -6 times 1/4 to the x power. Let me erase this stuff. Okay, let's look at graph number 2. That one. Would you say that this graph is increasing or decreasing? Okay, well, hopefully if we look at it, you can see that it is, if I zoom in even a little bit more, it is increasing. As it moves to the left to the right, it is going to increase. It's getting bigger. So this graph would be increasing. Again, where's my asymptote at? Let's look at the graph. Where does it start to level off at? Similarly, like before, it's leveling off at 0, it looks like. So y equals 0. Okay, again, your y-intercept is going to be at 0, -6. You can use Desmos for that, or you should just know it's the coefficient. And then end behavior. What's the graph doing as we go to the left? And what's the graph doing as we move to the right? We just have to say what y is doing. So what is y approaching for each of these? Okay, so as we move to the left, look at this graph. As we go to the left graph, it is going down forever. So on the left side, I'm going towards -infinity. So that means the right side must be approaching my asymptote. So my asymptote we already talked about was at 0. Okay. All right, let's finish up with these last two. I'm going to have you guys try these two and see how you do. So C and D, graph those and fill out the rest of this note sheet. So fill out increasing or decreasing. Where is the asymptote at? So where does the graph start to level off at? And again, these should both be y equals. The y-intercept part you can use Desmos for, or you can get just by looking at the equation. And then end behavior. I'll fill in the general for you. As x goes to the left, and as x goes to the right, we just have to fill in what y is doing. So is it approaching your asymptote? or is it approaching your positive or negative infinity? So go ahead and try these two, and we'll see how you do. Okay. If we look at graph C, okay, it looks like this graph is decreasing. Your asymptote is 0 again. It's still the x-axis. Okay, if you click on the graph, it will give you your x-intercept, even though we should know it's a half. Okay, so we have that this function is decreasing. Our asymptote is at 0. Our y-intercept's at a half. And as the graph goes to the left, it's headed towards infinity. As it goes to the right, it's headed towards your asymptote. So positive infinity, 0. Okay. Our last function here, let's turn this one on, 2 times 5 to the 5th power. This one is also increasing. It's getting bigger as it moves from left to right. Our asymptote, again, was at 0. We could see it's starting to level off at the x-axis, so same thing as all the other ones. My y-intercept is at 0, 2. And again, the end behavior. So what's the left side doing? It looks like it's headed towards our asymptote. The right side is going up forever. So the left side's approaching 0. The asymptote right side is headed towards positive infinity. Okay, so we did go over a lot of the key parts today for these exponential functions and their graphs. But when in doubt, just throw it into Desmos and you can kind of look at increasing, decreasing. You could see where it levels off. That's your asymptote. Okay, and remember, end behavior, we're talking about left side, right side. We're just using a little different notation now.